Now, as you all know that we have solids in two forms, that is the crystalline and the amorphous, and moreover you know that like when we talk about the arrangement, that is it is in order or it is not in order, we classify them as crystalline or amorphous, right. The ordered one is the crystalline. And you also know that the crystalline solids exist in crystal lattice, that is they unite to form a three-dimensional structure, that is the crystal lattice. So you all must be curious to know that how they actually get arranged in the crystals, or what kind of arrangement do you get to see in the crystals. So just we are going to start with the crystal lattice now. So first of all you should know that crystalline solids are those which have regular ordered arrangement. Right, you know that crystalline solids are that which have regular ordered arrangement, and mind that the order is long range order. That means we get to see this regular arrangement extending throughout the crystals, right. Now when we talk that how this crystalline solid get arranged, so actually these crystalline solid get arranged in a pattern that is called as crystal lattice. Now the reason behind we are studying crystal lattice, like what is the question must be coming in your mind, that yes we are in a need to know that how the arrangement of you can say the atoms are there, the crystalline solids, how they arrange themselves in lattice. But you know that studying of crystal lattice is also serving one more purpose. As you all know that most of the properties like physical properties are mainly based on that how the arrangement is how arrangement is there in lattice. So we come to know about the physical properties because the like different solids have different physical properties just depending upon that how they are arranged in the lattice. So we can say that crystal lattice is something very important, right. So what is crystal lattice? Now my question is that what is crystal lattice? So crystal lattice you can say is a three-dimensional arrangement of points in space. Right, it is three-dimensional, that means it will be extended in x-axis, y-axis and z-axis, and that arrangement of points in space is called as the crystal lattice. Here we will take the point as the constituent particles, that is atom, molecules or ions. You already know that the crystalline solids are formed of constituent particles, can be atoms, can be molecules or can be ions, right. So we can say crystal lattice is actually a three-dimensional arrangement of points in a space. And when we talk about arrangement, so I mean that the arrangement is the ordered arrangement, right. So I can just you can say transform this definition into a better way, that it is the systematic arrangement of points in space, and you have to keep in mind that the arrangement is three-dimensional. So what we will be saying that it is the systematic 3D arrangement of particles in space, and that something you can say that combination extend throughout the space and give rise to crystal lattice. As you can see in the figure, just look at the figure. This is the structure of NaCl, right. This is the structure of NaCl. In this, the purple one is the Na and the green one is chloride ion, right. So what happens, you can see that these are Na, these are Cl, so each they are just regularly orderly arranged, because as you can see this lattice, you get to see that yes the purple and green ones are present, but they are actually separated by the specific distances. You can see that if I say that between two purples I get to see one green, so it is happening all over the crystal, right. That means two sodium atoms, in between of two sodium atoms you get to see one chloride ion, right. So this same pattern is repeating in different direction, right. So this is what is called as crystal lattice. So what is crystal lattice? Just write in your copy. It is the three-dimensional arrangement of atoms in space, and obviously this arrangement extends throughout the crystal, and when this arrangement repeat itself in different direction, it gives rise to a crystal lattice here. So this is actually a crystal lattice. Now, what are the characteristics of crystal lattice? You should know that what are actually the characteristics of crystal lattice. So the first crystal lattice is that, as I said, that it is the 3D arrangement of points. So here by saying points, I mean that the constituent particles, that is the atom, molecules or ions, right. So that means those points refer to the constituent particles, that can be atom, molecule and ion. And you know that the second characteristic is that the second you can say the other name for these points is called as, they are actually called as lattice sites or lattice points. So I'm just doing it again, write in your copy. So the first characteristic is that these points refer to lattice sites or lattice points, right. Second, what is that lattice point actually composed of? So it is composed of constituent particles, and that constituent particles can be atom, can be molecule, or can be ion, because we already know that these are the three constituent particles from which the crystalline solids are made, right. So they can be atom, molecule, or ion. Third, what happens, like if you see that, suppose I have drawn this purple one as Na, and I have chloride here and I have chloride here, right. So these are actually you can say linked by the lines, and these lines are actually required to just show a linkage between them so that we can have a geometry, so that we can have a proper geometry, right. So this is what is the characteristics of the crystal lattice. Again, the first characteristic is that the lattice you can say these lattice points are actually called as lattice sites. Second, these lattice sites are actually composed of constituent particles, can be atoms, molecules, or ions. Third, these lattice sites or you can say the constituent particles are linked with the help of the line which is joining them, showing the linkage between them, and that is just giving rise to the geometry. So this is what we have the crystal lattice. Now, as we have the crystal lattice, so that means it must be comprising of a small you can say a unit also. Suppose if I draw this thing kind of if I say I have this kind of cube here, right. So suppose I draw it here. Suppose if I take this much part out of it, right. So I suppose this much part is this which I have drawn. So what you get to see that this much part is repeating throughout the crystal, right. So we can say it is the smallest portion of the crystal lattice, and you know that what is the smallest portion or what is the building block of the crystal lattice? It is the unit cell. It is the unit cell, right. So if somebody is going to ask you that what is the smallest portion of the crystal lattice which you get to see or which repeat itself in different direction so as to give rise to a complete crystal, that is something a unit cell, right. So unit cell is actually a building block of the crystal lattice which gets repeated in different you can say direction in 3 dimension, and the repetition is obviously the same one, right, and it gets repeated you can say throughout the crystal, giving rise to a complete crystal lattice. So we have, I am just showing you in the figure that what is the crystal lattice. So see, this is the unit cell of the crystal lattice, that is the building block of the crystal lattice. So here you can say we have certain kind of characteristics again which define this unit cell in a better way. What is that? See, you get to see these edges, or you can say these sides. These sides are actually called as edges of the unit cell. So we have edges of the unit cell, and they are demarcated as, or how they are denoted by A, B and C. And here you can see this is B, this is C, this axis, and this is A. That is why it is a 3-dimensional structure, right. Now between these edges, right, between these edges there is an angle. Between these edges there is an angle, and keep in mind that the edges are not always perpendicular to each other. We can have a different kind of you can say a unit cell where the edges are not perpendicular or the angle is something different, right. So it is not always that the angle is going to be 90 degree. Keep in mind, it may be 90, but it is not always that it is going to be 90 degree. So like but now at this moment our concern is not that what is the angle. Our concern is that where is the angle lie, where does the angle lie, right. So the angle lies between the edges. As you can see, this between C and B there is an alpha angle. I'll write here, alpha angle is between C and B edge, right. And you get to see one more angle, that is the gamma, between A and B. So gamma is the angle which lies between A and B. We do have the another angle beta, and it lies between, as you can see in the figure, it lies between A and C. So that means the unit cell is actually expressed in 6 parameters. Unit cell is actually expressed in 6 parameters. And what are those 6 parameters? Obviously the 3 sides and the 3 angles between the edges, right. And keep in mind the edges are not always perpendicular to each other, right. The angle may vary from this to that. So this is how you can say we just we need a parameter to define unit cell, and as we have seen that we have different sides, that is A, B, C, and it is possible that the sides, 2 sides are equal or 3 sides are equal or none of the side is equal. It can happen, right. So and even you can say likewise it can happen in the magnitude of the angle as well. that sometimes all angles are equal to 90 degree, sometimes 2 angles are equal to 90 degree, sometimes 3 angles are not at all equal to 90 degree. So that means anything can happen. But for this moment, what I want to tell you is that the unit cell actually composed of 3 edges. Second, edges may be perpendicular or not, right? It may or may not. Third, there is an angle between the edges, that is the alpha, beta and gamma. So there are total of 6 parameters which are needed to define the unit cell, right? That is the A, B, C and alpha, beta and gamma, right? So as I told you that these you can say the sides may be equal or may not be equal, or the angle may be equal to 90 or may not be equal to 90. So depending upon that, we get to see different type of unit cells, right? We get to see different type of unit cell. Just look at the figure. See. Here we have different type of unit cell. So as you can see, the first and the simple one is the simple cubic, right? In this, what you get to see, all the 3 sides are equal, that is A is equal to B is equal to C, and likewise all the sides are perpendicular to each other. That means the alpha, beta and gamma, all 3 are equal to 90 degree. So whenever you get to see that 3 sides are equal and alpha, beta, gamma are equal to 90 degree, so you should know that what is the structure of the unit cell. Obviously it is the cubic one. Now, second is the tetragonal. In this, what you see that A and B sides are somehow equal. You can see that A and B sides are equal, but they are not equal to the C side. As you can see, the C one is the longer side, right? So that means it is not at all equal to the C. But as far as the angles are concerned, the edges are perpendicular. So again, alpha, beta and gamma are equal to 90 degree. So whenever you get to see this kind of condition that A and B are equal and C is not equal and alpha, beta, gamma are still 90 degree, so that means it is a tetragonal form, tetragonal unit cell. Third is this one, in which none of the side is equal, neither the A, B, C, none of the side is equal, but still they are perpendicular to each other. So that form is something called as orthorhombic, right? I think you are clear with the 3. Cubic is that 3 sides are equal, 3 angles are 90 degree, right? Tetragonal is that in which A and B is equal, but B is not equal to C, and the angles again 90 degree. Third, orthorhombic, none of the side is equal, but still the angle is 90 degree. So these are the 3. I think you got an idea about these 3. Now next we should do with the remaining 4, because actually they are total of 7. Next what we have is hexagonal, right? Now what happens in hexagonal, right? Before I tell you hexagonal, just keep in mind the monoclinic one. You'll get a ordered arrangement, or you can say you'll have a good idea to learn. The other is monoclinic. Now what happens in monoclinic? 2 sides are equal, but the third side is not equal. As you can see that A and B is equal, again C is not equal, as it happened in the tetragonal one, right? The similar thing is happening in the monoclinic. But as far as the angles are concerned, like in the tetragonal, alpha, beta and gamma, 3 were equal to 90 degree, they were perpendicular to each other. But in this case, alpha and beta are 90 degree, but gamma is maybe some other angle, but probably it is not going to be 120 degree, right? So you can say that it is monoclinic, like if we talk about sides, it is similar to the tetragonal. But if you talk about angle, alpha and beta are definitely 90 degree, but gamma is something not equal to 90 degree. Next we have is the, let us take the hexagonal one. So again in hexagonal, 2 sides are equal and 1 is not equal, right? So A is equal to B, but it is not equal to C, as it happened in the monoclinic as well as in the tetragonal one. And when we talk about angles, so alpha and beta are equal to 90 degree, and gamma, as I told you that in monoclinic it is definitely not equal to 120, but here it is equal to 120 degree, right? So this is the hexagonal one. Then the next form we have is rhombohedral. Next is rhombohedral. In rhombohedral, what we get to see that 3 of the sides are equal to each other. 3 of the sides A, B, C are equal to each other. But when we talk about the angles are not equal, and definitely they are not equal to the 90 degree. Rhombohedral is actually similar to this orthorhombic, right? So see what happens in orthorhombic, 3 sides were not equal, but in rhombohedral 3 sides are equal. There all angles were equal to 90 degree, but in rhombohedral none of the angle is equal to 90 degree. The last but not the least form, that is the triclinic. In this, none of the side is equal, and moreover none of the angle is equal to 90 degree. So these are actually, you can say, the 7 types of unit cell which we get depending upon the edges and depending upon the angles, like whether they are perpendicular or not. So this is what we are going to do. Now we are going to start at what are actually the unit cell categories.